So in another model, I had this setting, which is similar to what I suggested yesterday, which is that we have the utilized capital is given by the level of output divided by an average capital productivity. You define the utilization rate as the ratio of utilized capital to the opening stock of capital. The stock of capital grows with the standard identity, and investment grows with this GK, net investment plus depreciation. And net investment depends on the utilization rate. So a higher utilization rate will imply an increase in the stock of capital. So this is not so different from what we had, because what we had well, what we had was a little different. Let's see what we had in the last R equation. So we had investment given by a constant plus a difference between GDP and target GDP and depreciation. So we can try to modify this. Let me also open the e-views. I don't see the e-views. Yeah, this is not shared with you, so let me. So what we want to have now is this we call that what I call beta 0 plus beta 1 times utilization rate and I want the utilization rate to be given by the level of output over let's call it productivity of capital divided by the opening stock of capital, and what else? I need to check that the investment will grow as in this equation. From GK plus the depreciation rate. So now we have to find values for these betas, these additional variable PIK, and we should be set. What I had in here was not working so well anyway, so let's try to start with 1. And we want the beta 0 I think we can start with some simple numbers, because what we will have here is if this is 1, oh, sorry, if this is 1, and we want this to be 0, then this could be something like 0, 0, 1, and this could be minus 0, 0, 1, so that we have a 0 for steady state. So let's see whether this works. And it is not bad, I would say, because it's not steady state, but it's not exploding. So both GDP and the stock of capital are slowly converging to a steady state. The output to capital ratio is converging to a little over 1.01. Let's look at the other stocks. The stock of bonds is also converging to a reasonable value. And what else did we have? We had the deposits. So this also looks okay, and we wanted deposits to be equal to loans. And the hidden equation is also okay, it's respected. So the model looks consistent. It has not reached the steady state yet, but maybe if we run the model long enough, let's see what happens. Yes. So the model, we can look at the steady state, and I guess that also they should be stable in values. Yes. So now we can use the model simulation results to set the starting values for the parameters. And let's do that. Then we convert everything into R. So we started from GDP, and GDP in the steady state is slightly higher than 1070. The stock of capital, I think, is going to be equal to GDP. Yes, it's going to be equal to GDP given the parameters we have chosen. The stock of bonds is converging to 862, so slightly less than what we had. These were given by investment is endogenous, so we don't really need to provide the starting values. So let's see what happens now. But still, this converges much more quickly, but still the starting values are not exactly what we want. So I guess you want to have this in RStudio. So we need to make the same changes in here. So the investment equation is now given by this, what I call GK. So we need a new variable GK, and this will be less the depreciation multiplying the opening stock of capital. So we won't need this anymore, and we need to create GK. And provide a starting value, I guess. We need starting values for everything here. Then we have this UR. So again, we need to create a variable. Provide a starting value. And add the equation. And this was GDP. Now this PIK can be a constant. This should be divided by K of the previous period. So here we also need to define PIK. And PIK can be simply set like this. What did I use? I think I used 1 for the value. Yes. So we still need one more change. No, maybe, yes, we need the equation for GK. And we had this beta 0 plus beta 1 times UR. And we need to provide values for beta 0 and beta 1. Okay, so hopefully this should give us the same outcome. But there's something different here. So there's something, maybe it's the equation for the stock of capital. That should be the same. Yeah, this is the same. So let's look at investment. Investment is the same. Oh, no, it should be plus, not less. Yeah, now this looks more like it. Can I plot the capital? Yes. Okay, so this is working, is converging more slowly. Now in these charts, we were looking at 2,000 replications. Now we only have 100. So I think that if we have the same, we should get, yes, it's converging to the steady state. So I don't know whether you wanted to recheck our algebra to try to find the algebraic solutions, which can be a little tedious. The other thing we wanted to investigate is what happens when the interest rates are not zero, because here we simplified and now are they're all zero, all the interest rates. So now we have a nice steady state. What if we bring back the interest rates to positive values? So what we had at the beginning was, I think, 2% for deposits, 1% for deposits, 2% on bonds, and 3% on loans. This will imply a profit for banks, which is distributed, should not make that much of a difference. It will make a difference to the government spending. So let's see what happens now. But basically, the outcome is the same. It's just a matter of a slightly different level of GDP in equilibrium. Let's look at the, I think we do have energy. No. Oh yes, I called it GDEF. So this is the government budget and it converges to zero, the steady state. And I expect also the change in household wealth should converge to zero.
But that was the deficit with respect to GDP, right? Or was it?
No, it was the level.
The level, oh, okay.
Because if we create wealth, no?
Mm-hmm.
And we generate revenues and we'll close with that.
Okay.
No?
But we can see what happens now. Now we have a steady state, nice steady state model. In 250, it has stabilized. Usually, it's a good idea to shock the model when it has reached a steady state. So here, yes.
The GDP will grow or
No, it's constant.
no? When you increase the
Yeah, this is what we're going to check now.
okay.
So let's assume a shock to the interest rate on bonds. Starting in period 250, when the model has now stabilized, let's increase this by 2% and see what happens. So we want to look at GDP after the shock less the GDP before the shock. And this is actually, it's fluctuating in a funny way here. So one of the things of these models as we have written them is that what is the role of interest rates? It's only to create income for the creditors, but you don't have any effect on the debtors. So a mainstream would, shout out. and say this is crazy. So we should actually also in this type of simple model have some negative feedbacks of interest rates on investment or consumption. Because I don't know exactly what is happening here. So the increase in the interest rate obviously increases the income of the households. But then I guess there will be no further increase in the income. They have to pay higher taxes. So look at what happens to the bonds. Oh, this is not something you want to get. I mean, this, we can think about this, but this is unexpected, I would say, because this is saying that with the higher interest payments imply a fall in the supply of bonds. So they imply an improvement in the create a surplus. Now this is the ratio of the stock of bonds after the shock and before the shock. So this is instead the difference in government deficit. So the government deficit should increase with the interest rate. Yeah, there is a mistake in the model. See, you always have to check the properties by running shocks, and we put the interest payments as a revenue instead than a payment. So we have to fix this and hope that the model will solve as nicely as it did. Let's check that this was not also in
the beginning. So.
Yeah. I don't think we have GDEF in here. Yes. But here it was correct. So here we didn't have any problem. So let's redo the baseline. Let's make sure that the baseline is converging. Yeah, it's converging as it was. So let's redo our exercise of increasing the interest rate. Yes, now the deficit increases first and then drops. So let's look at the impact on GDP. And GDP is permanently higher because of the increase in income, but then stabilizes to a new steady state. So what we do usually, and what most I think Godley Lavoie do in some models, is to include an effect of the interest rate on investment. So now we do have a stock of loan. And firms are paying a stable amount of money on their stock. So we could either have a direct impact of the interest rate on the growth rate of the stock of capital, or assume that the debt to income ratio of firms will reduce the investment. One of the to hypothesis. So first of all, let's save this, and we will save the modified model with a different name. So my suggestion to keep things simple could be to have an additional variable here for the interest rate on loans. And what value should we assume? So you always have to think at the magnitudes of this stuff. So RL is now 0.03, 3%. And what would we expect if it increases by 1%? Expect the growth rate to be permanently reduced by what? Half a percentage.
We haven't tried just to change also beta 0 and beta 1, because so far they are canceling each other out, right?
Mm-hmm. Yeah, only in equilibrium, otherwise they will have an effect.
Yeah, exactly, but we haven't tried to see the effect.
No, not yet. This is a good point. We may, before we do this,
Exactly, before we include the effect of the interest.
let's see what happens if we shock the autonomous component of demand, which should change the utilization rate. So I'll just change the variables to shock. And let's increase this by, I don't know, 5% of GDP. So this is the multiplier, which is very large. Let's see what happens to the utilization rate. So the utilization rate increases. I think this is quite nice. This increases temporarily as government expenditure increases, so output is larger than what you would like to have with this given stock of capital, and this triggers investment. So investment increases until the utilization rate goes back to its steady state value and everything stops. So this is what we expected, right?
So just a clarification question. So they go back exactly because there is a counter effect, right? So because they are canceling each other out, why they go back to the?
No.
Okay, then I didn't understand why they go back to the utilization rate.
Well, there is an implicit target utilization rate, which is given by the this variable PIK, so the capital productivity. So what happens is that if you shock if you shock an autonomous component of demand, then the utilization rate increases. This triggers in additional investment, so the stock of capital increases and utilization rate goes down.
Yeah.
Where maybe your question is whether the level of the utilization rate depends on the parameters, and the answer obviously is yes. But I think that now that the model is stable, if we change these, what was it, this beta 0, I think the model should stabilize at a somewhat different level, but should not explode.
That was my point.
Level
Exactly.
of utilization.
Hmm?
Of utilization rate.
Yes, we can try. So what if now beta 0 is minus 0.001 and it works. So keep the magic number in case something happens, and let's have a positive rate. So now in the beginning, investment will grow. So let's look now at the GDP. Now
Will explode.
it is exploding, yes. Yeah, because I think we need to fix something else.
Because in the way we set up the equation for GR, exactly like, maybe when you try to publish this, they will ask you, well, what's the theory behind this? It's very ad hoc, I want to say, ad hoc
This
for
one?
the simulation.
This model?
In particular, the equation for GR, for the rate of growth of investment that we have set up in this way, with the specific value for the betas. So I expect that, okay, now it works and it's nice, but when you want to,
It does not work. This is converging to 0 to 7% utilization rate. So we have chosen the parameters in a somewhat arbitrary way to create values which are realistic.
okay.
So if they are not realistic, the parameters are not okay. So if you use econometrics, then you're safe because it's the outcome of the estimate given the data. But if you're using intuition, so where do you take the numbers from? And take the numbers from other econometric studies or from averages, but you want the model to create reasonable values. So if the utilization rate goes to 7%, there's something wrong. So you could see actually what if we change this only slightly. I think it may still create problems. So you see, as we increase this value, we will have a drop in the utilization rate and GDP will increase.
Is it reasonable for utilization rate 50%?
Hmm?
Is it a reasonable value now, the working 0.5 for B1?
Let's just have this at 0. Now 0 is reasonable. So 0 is saying that the growth rate of the stock of capital only depends on the utilization rate, and we get a stable GDP, a stable utilization rate, which will be lower than what we had. It is converging to a very low value. But there is another point which is that in this type of models, the level of output will depend on the value of the exogenous variables and the multipliers. Now, the exogenous variables here, I think, are only two, and government expenditure and this beta 0, which is the autonomous component of investment. Everything else is endogenous. So if you put to 0 both government expenditure and this, then GDP will be 0. And the higher this beta 0, the higher the level of investment. And since this is in terms of growth, then you can have these explosions if it's too high. So, yeah, this is okay, but it's generating too low a value for the utilization rate. So this is getting too low. So I think what we had was good. Now, you may think that this is not so realistic, but let's complete what we were discussing. So we were discussing the introduction of the interest rate. So, and I think I copied this down. No, I didn't. So if we want GK to go to 0, roughly, so this is almost 0. Our beta 0 is minus 0.001. Our beta 1 is 0.001. And our utilization rate in steady state is, this is still going very low. Also, let me rerun this again. Yes, now this is going to 1, as in our previous simulation. So, since we had minus 0.001 in here, this was roughly 0. I think it should be actually 0. Now that I've fixed, yes, this goes exactly to 0. So if we introduce a value of 0.03 in here, and let's say that we fix this parameter beta 2 to be 50%. Then this will become 0 minus 0.015. And in order to get 0 for GK, you want to increase this by 0.015. So the new beta 0 becomes plus 0.005. I don't know whether you followed my math, and we can see whether this works. But in principle, since RL is exogenous, for our choice of parameters, this should give us exactly the same result that we had before. So let's see whether this is true. GK goes to 0. As before, UR should go to 1 as before. It does, and the GDP should stabilize like before. But now we have a different impact of the interest rate. So if we shock the interest rate on loans by 1%, we will have the negative impact. So now we have a more traditional effect. And if the decrease in investment more than is larger than the positive effect on the income of the rentiers.
There is just a level effect on GDP.
Yes, there is no growth. I don't think there is a growth effect. Because this goes down to the utilization rate, I think we'll go back to where it was. No, it's permanently higher than it was.
It seems it's the same effect as changing beta zero. No?
You think so?
Because it's changing the investment.
They're changing. Yes. Yeah. No. You are correct. We are changing the intercept of the growth of capital. But with additional effects on the interest payments now. So the investment decreases and the model.
You don't understand the
Yeah, the point is the interest, since the interest rate is now larger, the equation is saying that you reach steady state in here. For a larger RL and the same GK, UR must be higher.
Okay.
So there's a permanent drop in the stock of capital relative to GDP. The other thing which you usually want to do, so did we copy this into here? So we added a beta 2 times RLI and beta 2 is 0.5 and now this is plus 0. 2 zeros, I think. 0.005.
It was 001, and then we have to.
Yeah. It's minus 0.001.
Yeah.
Yes. So now, yeah, it looks like it's working. It goes to 8. No, there's something wrong here. We have not updated everything. So what else did we change? Oh yes, we didn't update the interest rates. Yes, now it's like the EU's counterpart. What we always do also in these models is to link the interest rates together. So you usually do this with kind of a markup and say let's say the interest on bonds is the reference interest rate. And then you say the RL will be given by RB plus R premium. Let's call it RLP, for instance. And RD will be RB less an RD premium that banks take. So basically this is shifting the exogenous values from the interest rates to this premium, but allows you to work with a single interest rate, which changes the whole structure of the interest rates. So here we have RLP and RDP to include. RFP will be 001 and RDP will be also 001. And everything should be exactly as we had it. But now, when we shock RB, the whole structure of the interest rate is changing. And now this will have an effect on investment, given that we have included this into the investment equation. Why is it? This is increasing this much? Because the investment drop, as we expect for the higher interest rate on loans, but consumption increases more because of the additional interest gained on bonds, and the effect of consumption is larger than the effect on investment, so that you have an increase in GDP. So let's also modify this in R. And we need to add these two additional equations, RL to RB, plus these are LP. Okay. Okay, but here, how do you do a shock in this code? You have to redo the for.
No, you can use the if operator.
In the loop.
Yeah. If the I index is larger equal than a certain period, so year, then you can change a specific value. Then you can define, maybe you have a variable which is called shock, which is always at 0, and then that from a certain period on it goes to 1, for example. That would be one way to do it. Or maybe change the level of a variable. Usually, I don't know, 50, and then from the period on goes to 55, and then it's permanently increasing government spending.
Yeah, but basically, since all the exogenous are updated here, obviously here we want to drop this now because we endogenize them. So since they're here, it's sufficient that in here I say if I
Parentheses, yeah.
I equal 250, then I have curly brackets.
Curly, yes.
So I want to increase RB. So RBI will be boom, RBI will be larger than and then I can use else if else.
Yeah. So you can also,
If else,
no, it's slightly different in this case. You cannot use because this if else is a function that allows you to define something in one row.
mhm,
Here it could be done also this way, but in this way you set up the loop, you have to use the else at the end of the curly braces. So it's if I, but if
mhm.
you say equal to 250, it means that the change will take place only in I equal to 250. So
Yes, but it is a step, and then it will in 251 it will copy the previous value, so it will still be
okay, because you set up
yes.
this way.
So you have to replace the whole line. You have to take the current selection RB down there.
Exactly.
And
Yes.
take
Exactly.
But this has to be valid if I is not 250. So
And then there would be your else.
the else is after the curly brackets.
Yes. Else open curly braces, and then the other piece of RB.
Yes.
But there are other ways also to do this. This is one.
So this would be how we can do that.
Yeah.
Oh, this. Oh yes, because here we are only looking at the the short solution, not the difference with the baseline, and we still had this. Yeah, it looks like it's exactly replicates what we've done in Nevius. Okay, time for coffee.
Yes.
Yeah.
To add. Problem is it's not easy to compute quickly all the values which will provide nice stable solutions. So we can try.
We can start with the fact that the balance of payment is in equilibrium. So
Yes. So let's now call it simple open. I would suggest that we revert to a steady state model. And if I simply put this to 0, this should be again a steady state model. So now we should be able to find reasonable values for exports and imports that are coherent with this steady state value of GDP. So this is 1164, GDP is 1164. So we could add an equation for imports, which is, I don't know, a reasonable value is usually 30% of GDP. And we may want to have add something, a constant here. So if we have 30% of 1164, it's going to be 349.2. Let's say that we want total imports to be 400. So the constant should be 50.8. And no, we want exports to be exogenous, and now exports will be 400. So we'll have XGS equal to 400. And we need to modify the identity of GDP to include exports and deduct imports. So far, this is incomplete, but we can look at our imports and check whether they converge to 400, and they are slowly converging to 400, but then they are declining later on. I don't really know why.
Seems like a very small difference at the beginning, so which is maybe has to do with the rounding.
Yeah, well, let's complete the model and then we'll try to look for stable solutions. So what else we have to have in here is we need to add the interest payment on foreign assets that will need to be specified. Nothing is going to change in here. We will want to add the current account balance, which is exports minus imports plus the interest they pay on foreign liabilities. We need to add the change in liabilities, and we said that they will be given by the current account balance. So if the current account balance is positive, this means the foreigners have to borrow and increase their stock. And now we have to modify the demand for bonds by the private sector, which was here. So now this will include the stock of foreign assets. And at present, households are buying all the bonds, but now I don't know whether it's sufficient to have only one foreign asset. Usually what you have in reality is that the foreigners buy the government bonds, and then you have a foreign asset accumulated. But if we don't do that, this FL may be negative or positive according to whether the current account balance is positive or negative, and it should not matter that much. But now what we are implicitly saying here is that the private sector will take whatever amount of borrowing is required by foreigners. I think. FL is not defined. Let's put this at 0 to begin with. We need the interest rate on foreign bonds. Let's put this also at 0 to begin with. And let's look at the model. So let's see whether we have something to be endogenized. So now our exogenous are the parameters we had at the beginning, the growth rate in government expenditure. We now have two interest rates which are exogenous and exports. So everything looks okay. But GDP now is no longer stabilizing. But if we restrict this to the first we can try to see what's happening in here that makes this go down. So let's look at the current account balance. So this is improving. Let's look at the utilization rate. So this is dropping. I think we have to play around so that the share of the components of demand are stable. Because here I think that investment is falling relative to GDP. Actually, it's increasing as a share of GDP. So the parameters we have do not imply stability. Why, Hackard?
What's the fraction of GDP?
In principle, as long as GDP is stable, it should follow GDP. So it should not be a source of trouble.
And the exports are not changing.
Exports are stable and exogenous. What about the wealth to GDP? So this is also potentially a source of problems. When this starts to go down, consumption will be reduced, and this will bring down GDP. But I suspect we are missing something in the accounting. Okay, we managed to find a nice simple growth model of a closed economy. And now we're trying to check whether in 50 minutes we can have an open economy stable model. But so far there's something which is not stabilizing. Let's bring back all the interest rates to 0 to simplify the story.
The growth rate of government spending was already back to 0.
Yeah.
Yes. Or maybe I don't think this is a good idea anyway. Let's keep it as they were. 1, 2, 3. Yes, G is not growing anymore. And this is what we have used for imports.
Okay.
So your debt is increasing and your wealth is falling.
It's worth it for, okay.
But it's not enough to.
But we have some problems because this, the net lending, I think, are not what they should be. So here investment is inclusive of depreciation, and this should give us 0. But it's not exactly 0. There is a small discrepancy. And what we should have is that the sum of the net lending of the households plus the net lending of the business plus the or minus the government deficit plus the current account balance should be 0, but they're not. So there is an accounting inconsistency that we should fix. Well, one inconsistency is in the tax, because the tax now should include the interest payment on foreign wealth. But since our F is 0, this is not where the problem lies. Now, sigma is 1, so this is not creating any trouble. This is still, no, now this is exploding. But why? F is not there, and it's 0. No, you need more time to work this out properly. This does not seem to be wrong.
Balance,
Hmm?
where the current account balance enters in the this current account should be imports minus
Current account balance is exports plus interest received from abroad less imports.
because the sign of the exports should be different from the RF times FL, no?
Yes, but this RF is 0 right now. To
Maybe
keep things simple.
imports minus exports.
Because variation in foreign debt, if positive, should reflect a current account deficit.
Well, I have to think about it, but maybe we are assuming too much market clearing by households, because now we're saying that this stock of foreign wealth increases with the current account balance, and whatever amount the foreigners need to borrow is supplied by the household. Whatever the government needs to borrow is supplied by the households. And the wealth of the households is the result of their net lending or their saving, and deposits are the residual. And I think that deposits are still equal to loans. Yes, this is at least this is the hidden equation, which is still valid, but there is some inconsistency somewhere. One thing that you can do when you have this type of trouble is what I discussed with you for the empirical model. So I can move all the equations with the parameters, or the equations which are not accounting identities, to the bottom of the program. And now all the equations up to here should be accounting identities. So I can solve the model only for the accounting. Sorry, let me also shift all the definition of the variables to the top. So that when I solve the model, GK is not defined. Why should I have GK? Okay. And MGS is also possibly not defined. Okay, so now I should have that all the simulations are identical to the data, but they are not. So what I can do is to look at the sequence in which things are computed and make sure that the starting values are such that at least the identities replicate the data exactly. So this is what I did in my code yesterday. It should be somewhere, maybe in here. Yes. So I can use this portion of the code So again, this creates a list of the endogenous. This creates the, well, this is not really very relevant. This creates the group of endogenous variables, which is also not necessarily relevant. This specifies the sample for the solution. This solves, and now this creates my loop to show so cap is not defined. NLB is not defined. NLH is not defined. All these are not defined. UR is not defined. VB is not defined. Basically, all the endogenous were not defined because we did not need them to find a solution. Okay. And now I can at least check which variables are different, by how much they are different from my starting values. And I can try to work out how to have the model solve. So if I have enough time, I can go through the equations one by one. So I, for the accounting identities, depends only on the exogenous variables. So I can go and look at the equation for I and check whether at least the starting values are in line with what I want. Actually, this may also be visualized on spreadsheet, which is another way to arrange the solutions so that we see what's happening. I'm not sure we have time to do this, but basically another thing that I could do is to take the list of exogenous and the list of exogenous and put them in a spreadsheet according to their order. So no, I dropped this. So these are the exogenous variables we are using right now. So in my spreadsheet, I can create a sheet in which I have the exogenous first, and I can copy their values from here. And then I can have my endogenous list in here. And now I want to arrange them in the order in which the model is solving for them. So it's going to take a little while, but we want to look at the endogenous. And the first one will be I. And we want a column for the periods. So here we will start from the second period, and investment depends on the stock of capital, which is found later on. So basically, I want to have this as a list. I'm not sure that it's easy to do. Sorry, I'm just doing some very quick and dirty procedures to drop all these brackets out. Didn't work as expected. Okay, so let's substitute Okay, I've done. Delete the column. Select all. And finally change this to okay. This is what I wanted to achieve, is an ordered list of my endogenous variables so that I can fill the numbers in. And actually, I can also use this in eViews. Show me these variables in this order. Okay. So the work you may want to do if you're desperate and you don't know how to fix the problem in the model is starting from the second period. You take the equation you have in the model. So for investment is GK plus DPR times the opening stock of capital, and you use the spreadsheet to compute the same formula. So this is GK plus DPR times the opening stock of capital, which will be what we have in here. And this will give me 107. And we can later play around with the values of the exogenous or the values of the opening stocks in order for this to be exactly what we want. And now G is a constant, and we don't need to specify. GDP is equal to consumption, which is currently exogenous, plus investment, plus exports, less imports. And well, this is not really relevant. So we here already want to adjust some of the numbers so to have exactly the steady state value we want to reach. This is the wage bill, which is given by the fraction row of GDP. So again, we use the spreadsheet to compute it. The gross operating surplus is GDP less the wage bill. This is an endogenous, but it's basically fixed. These dividends are given by this formula, this sigma, which is 1, so we can ignore the sigma for the time being. So they are the profits less what firms pay on the loans, and the loans of the previous period are here. And we subtract also the depreciation rate times the opening stock of capital. Looks okay to me. and so on. So these were the dividends of firms. So I don't want them to be here, I want them to be here. The dividends of banks are equal to the interest rate on loans times the opening stock of loan minus the interest rate on deposits times the opening stock of deposits the taxes are messy. Anyway, I'm not going to do this for everything. I just wanted to show you the procedure. And if we want the model to stabilize immediately at a given level, we can try to play around with our parameters until we get convergence of the starting values and the following values. Then when we endogenize things, this will have to be brought to the variables that we identify. Sometimes it may be useful to do this, but usually what I usually do is to have a mixture of trial and error and a mixture of algebraic analysis. Try to look what should be implied by using algebra. I know here there must be a simple, stupid mistake in the identities, which in a model which simulates for 2000 period accumulates, a small error accumulates and makes everything explode. Okay, so I could also stop, but I'm ready to address other questions or curiosities you may have. So this simple open is not working.
I think that it was really nice to see from yesterday how to really start to think about the model, starting from the Excel in our case, so with the balance sheet and the transaction flow, and then building up and working out, you know, the steady state level, etc. It was really instructive in a sense. So I really appreciate that. And also, you know, it's extending it first within our investment, and then with the was really interesting. Yeah. But exactly, my question was how you reconcile all of this with theory. So because we have my feeling that sometimes you have to, in order to make the model work, you have to find a compromise, and maybe that can be contradictory with some theory that you want to show or support, or that you come from, or some I don't know.
No, but I told you the parameters are usually taken from the data. So the propensity to import, the propensity to spend out of income, we know what type of estimates we get from a country, and we use values which are very close. So the only trick is on these autonomous components. But I'm not so sure that this is in contradiction with the theory. So, Eka, just to bring you into the conversation, we were using an investment function, which is basically, it's not here, it's GK. Oh, well, yes, it's this equation here. So UR is the utilization rate, GK the growth in the net stock of capital, and this beta 0 is a constant. So given our starting values for the utilization rate and beta 1, I set this beta 0 to a negative value. And Alessandro was a little upset because he said, well, are we assuming that for a given utilization rate, huh?
You have saving out of wages in the model.
Saving are out of wages and profits, and wages and dividends.
You have saving out of wages, then you can set the constant.
Yeah, but then what I showed is that if we modify this equation and we add an impact of the interest rate as the chapter 11 of Godley-Lavoie, then the constant becomes positive because now you've added a negative component. So the purpose is to have a growth rate which is stable at a small level. And so Alessandro fears that the value you use for this constant component of investment should come from the theory, while I'm very pragmatic and I say, no, it depends on the other parameters.
This is something, I mean, we always have, we know from the very basic model, if you don't have anything else, so no other component in the investment function or no saving out of wages, then it cannot be zero, it cannot be negative because otherwise you get a negative equilibrium.
Right.
But that's not, as soon as you have other components in your behavioral functions, then it can differ from zero.
Yeah.
And can even be negative. And the same is, if you, what I always tell my students, if we estimate consumption functions, very simple ones, the constant may be zero, or even negative, because we may have a nonlinear relationship in the data, which then, if we linearize it, may give you a negative constant for that estimated function. And here it's a bit similar, I would say. It is, I mean, in this function, you cannot interpret the constant as the triangular growth. Because your utilization rate is free to vary, so it's not fixed to any normal rate, it's free to vary in each equilibrium. So it can be any number. So,
yeah, I think what is more difficult to reconcile is the theory of investment with the estimates, because it's usually very difficult to get a good estimate of investment.
but what you have here, I think, is, as far as I read the literature, is basically in line with the literature. So you have, what we have is usually a significant effect of the accelerated terms. So
yes.
Sales, GDP, or utilization, or whatever you have. And the rest then becomes very messy.
Yeah, I mean, what the mainstream want is the impact of the interest rate, and that very often is not there. And therefore, you have this result that in stock flow models, an increase in the interest rate increases GDP because you only have the impact on income.
And have an impact on consumption, negative impact.
Yes. But also, it's not so easy to find the impact on the demand for mortgages, for instance. It's more easy to find the link between the debt to income ratio on the demand for new mortgages. So if the debt of households increases a lot relative to their disposable income, they're likely to stop borrowing. But the link with the interest rate is not so easy to find.
Consumption of durable goods by credit.
Maybe. But it's what I think from my personal experience in buying durable goods is that the practice that I think they follow is that they offer you a scheme of repayment which is convenient for you in terms of your income, and they adjust the timing in a way which is completely at odds with the logic of interest payments. So the logic they follow is they want to earn from lending to you. So you may think, well, if the repayment takes 10 years instead of 5 years, it's more risky, so they will want to increase the interest rate. but they don't do that because otherwise it's going to cost you too much. So you may have a lower interest rate for a long-term loan than for a short-term loan. So it's, maybe this translates into a difficulty in estimating the link between the demand for loans and the interest rate.
Then it changed too much.
Hmm.
The base interest rate from 0 to 10. How you can have some effects on it.
I didn't hear you well.
So you could change, have a big change, the base interest rate.
Mm-hmm.
It can have an impact. Also, you have all these changes in
Yes.
time.
Yes.
It can have an impact.
Yeah, no, I'm not denying that there will be an impact. So in Greece, when they joined the euro, their real interest rate dropped dramatically.
Yeah.
And they also got easier access to credit, and they started to spend whatever they could. Okay. So
Thank you very much, Gennaro, for the intense seminar. I haven't attended only the first day. But my feel is that at least those who have attended in person